Take a look at this map. This is the Krishna River Basin, and it covers nearly 8% of India's total landmass. It spans 4 states, Maharashtra, Karnataka, Telangana, and Andhra Pradesh, forming a massive political footprint in the heart of the South. Within these borders live over 74 million people. For them, this water system is the primary driver of agricultural production and industrial growth across peninsular India. The main stem starts as a tiny stream high in the Western Ghats at Mahabaleshwar, at an altitude of 1,337 meters. It traces a 1,400-kilometer eastward path across the Deccan Plateau, eventually emptying into the Bay of Bengal near Hamsaladivi. But the system has a natural vulnerability. The river is fed entirely by seasonal monsoon rains. When those rains stop, the natural flow drops, leading to extreme fluctuations in water volume throughout the year. To prevent economic collapse during dry seasons, humanity transformed this erratic natural watercourse into an interlocking grid of dams and tributary diversions. To understand how the basin survives, we look first to its right bank tributaries. These rivers originate in the high rainfall zones of the Western Ghats. They function as the hydrological powerhouses of the basin, providing the majority of its dependable stream flow. One of the most critical is the Koyna River. It joins the Krishna at Karad, generating massive hydroelectricity, though its large reservoir is tied to the 1967 earthquake that devastated the region. Further down, a sequence of other high-yield rivers joins the main stem, starting with the Vena, the Panchganga and Dudganga, and finally the Ghataprabha and Malaprabha. Then there is the Tungabhadra. With a catchment area of over 71,000 square kilometers, it is the largest tributary in the basin. It flows through rocky landscapes and ancient temple ruins, carrying deep historical significance dating back to the epic periods. Without the heavy monsoon rains captured by these specific right bank rivers, downstream states would lack the water volume required to sustain their crops and cities. The left side of the basin tells a different story. These left bank tributaries drain the semi-arid, rain-shadow expanses of the Deccan Plateau. The standout here is the Bhima River, stretching 861 kilometers from its origin at Bhimashankar down to its confluence near Raichur. It is the longest single tributary in the entire basin. Further east is the Musi River. This tributary flows directly through the city of Hyderabad, acting as a vital water source for millions in Telangana. Other key left bank rivers like the Dindi, Paleru, and Muneru continue the pattern, draining the dry northeastern tracts before meeting the main stem. While these left bank rivers contribute less overall water volume than the right bank, may allow agriculture to exist in the basin's driest, most vulnerable territories. To manage this uneven water supply, engineers constructed a cascading grid of megadams across both the main stem and its tributaries. Major upstream and mid-basin structures, like the Almaty, Jarala, and Sri Sailam dams, perform a constant balancing act. They hold back massive volumes of water for dry season irrigation, while releasing controlled surges during heavy rains to manage floods. Downstream sits the Nagarjuna Sagar Dam, an engineering project massive enough to rank as one of the world's largest masonry dams. And near the river's delta, the Prakasam Barrage acts as the final distributor. It spreads the remaining water across a vast network of canals, turning the region into the rice bowl of Andhra Pradesh. Over decades, this chain of megastructures has taken a volatile, seasonal river and turned it into a regulated, mechanical engine running the state economy. With 75% of the entire basin now dedicated to agriculture, the stakes for this water are incredibly high. Every downstream state is dependent on the states above them releasing water to survive. This map illustrates how the natural water flow is technically and legally fractured into 7 distinct subbasins. Competing demands and climate shifts routinely trigger intense legal battles over allocation, managed by the Krishna Water Disputes Tribunal. Engineering the river solved the problem of monsoon volatility, but it created a new problem: geopolitical friction between neighboring states fighting over a finite resource. Let's lock in the geography. Right bank rivers, like the Koyna and Tungabhadra, bring heavy rainfall. Left bank rivers, like the Bhima and Musi, drain the plateau. The main stem is controlled by a descending staircase of dams: Almaty, Sri Sailam, Nagarjuna Sagar, and Prakashan Barrage. Mastering this anatomy means understanding a fragile balance. It is a continuous push and pull between natural rain-fed tributaries and massive human engineering, a dynamic that defines the survival mechanics of peninsular India.